continue. Okay, so hi everyone. Today I'm going to talk about Anaconda and Jupyter Notebook and how you can easily run scientific computing applications on using this software package. So what Anaconda is a Python distribution. So why Python? So Python is one of the most used languages for scientific computing. The syntax is easy to understand and use, and Python has a lot of packages developed for it that will allow you to perform many scientific computing operations, such as array operations and things like that, without jumping through too many hoops. So Anaconda is a distribution of the Python programming language. So it includes many scientific computing packages such as NumPy, which allows you to do linear algebra and stuff like that. Matplotlib plots stuff for you essentially. SciPy includes a lot of algorithms that you can such as bipartite matching that you can use to incorporate into your programs. And Pandas is basically data manipulation. So these packages are already included in Anaconda. You don't have to install them yourself once you have Anaconda. And these are very useful for many applications. So Anaconda also includes a built-in package manager called Conda. And Conda, so if you want to install anything, any library into your Anaconda environment, all you need to do is type in Conda install something, and then it'll install that something for you without too much of a fuss. And you can also use that to update your packages and so on. And that's very convenient. It includes environment management for isolation of different versions of packages and other software. So perhaps you might have one piece of code which has certain dependencies, and you have another code which has other dependencies which are not compatible with the dependencies of that first piece of code. So if you want to run them both on the same installation, you can do that by switching between libraries, between environments. And we'll talk about environments in more detail later. And cross-platform support. So basically, you can install Anaconda on Linux, you can install it on Windows or Mac OS, and they essentially all work in the same way. So this is just an illustration of what environments can be. So let's say you have different applications that run on different versions of Python. So you can just have environment 1 with Python 2.7 installed and some version of some other packages that you might need. And then you can have an entirely separate environment 2 with Python 3.5 that is entirely separate from environment 1 and has its own environment variables and its packages and libraries installed. So if there's any conflict between the two in terms of versions and all that, you won't be affected. A code that needs to be run in environment 1 can be run here. If you need it here, you can run it here. And same for environment 3, if you need a specific version of NumPy, say 1.17.4, then you can open a new environment and install NumPy equals to 1.17.4, and it'll let you do that. So it's a very convenient thing to do. And yeah, so there's a download link for Anaconda here. If you wish, I could send it to the group. Basically, I'll send it to WhatsApp, but it doesn't mean I endorse WhatsApp, but it's for convenience. Okay, so that's the download link for Anaconda. And so once you download that Anaconda link, this is how it looks like when you get there. This is how it looks like. You just download Anaconda individual edition. There's an exe file. You just check the checksum if you want, and then you install it. It installs just like any program. So it's very straightforward. And once you are done with the installation, you can just go to just type in Anaconda, and then you get this Anaconda prompt, and you're in. So now you have an Anaconda prompt for you, and then you can. So here you are in the base environment, and base environment is the default environment that is installed for you when you first start using Anaconda. So if you want to look at the list of environments that you have in Anaconda, you can type in, I can make this bigger, can I? Wait. Okay, I can't make this bigger. Wait, can I? Properties. Fonts, okay, I can make this bigger. Oops, okay, all right. Let's make it even bigger. I think this will do. Right, so what you need to do, so conda and list, and then it'll show me that I have the default base environment. I have the ADJ-ENC environment, and I have the UGR environment. So these are the environments I have, and each of these environments contain different packages that I need to do my work. So let's say you want to create a new environment. Just type in, let's say conda create name first. Let's say demo. Let's say create name demo, and you can specify the version of Python you want. And this is really important if the code that you're running is only specific to a certain version of Python. So let's say for now I want Python 3.7. So I'll specify that, and I'll create the environment, and it'll tell me, ask me whether I want to proceed. I'll proceed by typing in yes, and it'll run the script automatically to set the environment up, and it's all essentially automated, and it's really easy. So so right now, let's say I want to enter this environment. So it tells me to activate this environment, use conda activate demo. So let's just type in conda activate demo. And so now you can see that this bracket from base, it has changed to demo. So it tells me that right now I'm in the demo environment. So so every line that I create on this command interpreter, it shows me demo. So that tells me which environment I'm in. And when I want to go back to the base environment, I can just type in conda deactivate, or I can type in conda activate base, and these will all work. But let's say I want to go back to demo, and I want to install this package called TensorFlow. So let's say I install TensorFlow. And let's say I want a version, let's just say, let's install the latest version of TensorFlow. So let's just install it. Yeah, and yes. So TensorFlow is an open source platform for machine learning applications. So there are lots of tools and libraries that you can use within TensorFlow that will help you build your AI models and train them, run them, whatever you want. And so it'll take some time to install. But basically, this is everything I'm doing here. You can do it on your own Windows PC. You can do it on your own Mac OS computer. It is cross-platform, so it will work everywhere. And if you're not running anything heavy, Anaconda by itself doesn't require much system resources. So you can run it on a laptop if you want. Yeah, so it's not something you need expensive hardware to run. So right now we are done with the installation for for TensorFlow on this Conda environment. So okay, so let's so that's about it with Anaconda actually. So this is where we can go to the next part, which is Jupyter Notebook. And Jupyter Notebook will be a bit more interesting because we'll show how to use Jupyter Notebook together with Anaconda environments to run your perhaps, let's say, an AI application. So let's see if we can do this. Okay, so what is Jupyter Notebook? Jupyter Notebook is a browser-based user interface for editing and executing Python code. So it allows you to edit your code and run it in your browser using your selected Anaconda environment. So you can use any environment you want, and you can just do it right in your browser, such as Firefox, Chrome, etc. The output of that code is displayed right below your code when you run it. So you can see, oh, okay, when I click the run button, oh, the output appears under the code, and it can be saved there. So when you save, it gets saved in your Jupyter Notebook file. And when you open the same notebook, say tomorrow, that the result of your previous execution will still be there. And you can also share that with other people. So Jupyter Notebook also comes in a number of blocks. So you can have, it's a notebook. So you can have different blocks of code, and you can run the blocks of code sequentially. So essentially, you can run, let's say, one step of your pipeline, and then you can see what the output of that step of the pipeline. You can print something out for you to debug things. And then when you're ready to go on, you can go on to the next block of code, and then you can run whatever there is in the second block, in the third block, and whatever. So all the variables in the code will be carried over to the next blocks. Of course, unless they're overwritten. So I'll go through the installation of Jupyter Notebook on Anaconda, but basically, you want to go back to base. So conda activate base. You want to go back to base, and actually Jupyter Notebook comes bundled in with Anaconda. So the moment you install Anaconda, you already have Jupyter Notebook, and all you have to do, really, if you don't want a new environment, is to type Jupyter-notebook, and it will just pop up into a browser window for you, and that's the Jupyter Notebook for you, right? So this is Jupyter Notebook, and but let's say I don't want to use the base environment. Let's say I want to use but okay, so let's go and see what environments I have. So right now, let's go to a demo. Say I want, okay, so 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 let's see what kernels I have. So the environments I have here, Jupyter Notebook calls it a kernel. We have Python 3, we have ADJ, ENC, Inc. We have UGR, which were the environments I had earlier when I showed you the listing of environments in the Anaconda prompt. So where's demo? So if you set up a Python environment, Anaconda environment, it doesn't get activated immediately for Jupyter Notebook. So you have to prepare it, and you do that by installing the kernel package in your environment itself. So let's say you want to use demo, the new environment demo with Jupyter Notebook. You have to install the IPyKernel library in the demo environment. So let's say we are going to conda activate demo. Yeah, and now, so what you can do now is you can install something, right? So you have to install this thing called Conda. So Conda is the package manager, as I mentioned. So all you have to do to install something on Anaconda is just to type Anaconda install. And in this case, I'm installing IPyKernel. So here's what I'm going to type. So so here we go. And it does everything for me again. And I say yes, I will proceed. Okay, once this is done, I have to configure it. So I just type Python m IPyKernel install -- user, and I set a name for the kernel within Jupyter Notebook. And for ease of use, let's just give it the same name for the kernel as the environment itself is called. So let's call it demo. And once this is done, it tells me install kernel spec demo in the directory. And now we can go back to launch Jupyter Notebook, and we'll see that we now have the new kernel, that is the new environment demo, in the list of kernels available. So every time you launch Jupyter Notebook, you have to start from the base environment. You can't start it from a non-default environment. So we go back to the base. We go back to base, and we launch Jupyter Notebook using the Jupyter-notebook command. Okay. And you just copy this link, and yeah, and you paste it into your browser, and this is what you get. So let's say I want to go to this notebook. So Jupyter Notebooks are saved in IPyNB files. So so every single piece of code, every bit of output, every bit of notation in the notebook is contained entirely within the IPyNB file. So let's say we have this, all right? So now you can select a kernel, and when you're asked to select a kernel, you see that the demo kernel is now available. So let's activate the demo kernel. And now the kernel is ready. So let's run the first block, which imports some packages for this thing. And let's hope it runs. Okay, so no module found, matplotlib. So what this means is we have to go back sorry, to Conda prompt. And let's make this bigger. Go back here. And of course, to install, we Conda activate demo. And we Conda install matplotlib. And it handles it for you. So it's really not much of a problem. Okay, so now we have this. And but let's relaunch our Jupyter Notebook because we've installed a new package. So let's see. Let's relaunch it. Should be ready by now. Yeah. Okay, let's see demo SMS vision CMN. Okay, let's say demo set kernel. So now when we run this first block, okay, it runs. So it tells me 1, and this tells me the order in which the blocks have been run. So here, 1 means that this is the first block to have been executed. And we can just go on to run the second block. And this second block it downloads a data set, a ready-made data set from online called Fashion MNIST. And it's a pretty standard data set for classification of images. So let's say, let's run this block. Okay, so we have keras.datasets.fashionmnist, and this is, so each image is 28 by 28. And so now we are going to load the data. So it's going to download, right? And yes, so it's loaded. And so here we reshape the images to how we want it to be. So 28 by 28. And the input shape is 28 by 28. So, and this 1 at the end means that it's black and white, like my picture now. So if it was free, then there would be free color layers and RGB. But here it's 1. So yeah. And now we normalize the input between 0 and 1 by dividing it by 255. Okay. And then we check the shape of the input. So, okay, so we have 60,000 images in the training data set, and 28 by 28 by 1. That is the color. And yeah, so and the labels. So we have images and we have labels. So so when we have images, the images are the data we are training on, and the labels will tell you what the data is. So for in this case, we have different categories of clothes in our images. Some of them are t-shirts, some of them are trousers, dresses, coats, sandals. All right, so the task here is to predict, okay, given this image, okay, can you tell that this is a t-shirt? Can you tell that this is a sneaker? Okay, is this an ankle boot, a sandal, a trouser? Okay, so that's kind of what we want to know, and we can train a classifier to tell us, okay, so we have a training data and a test data. So we'll train the model on the training data. So it will learn, you know, what a dress is, what a t-shirt is, what a pullover is. And when you give it the test data, you know, you're testing the model, you know, I'm giving you this image, and I want you to tell me what it is, and I'll see if you're right. So so we are going to do a convolutional neural network. So it's a sequential, this is a sequential keras model. So we have a convolutional layer, a max pooling layer, another convolution layer, another max pooling layer, and a flatten layer to flatten it all into one. Yeah, right. And we make it a dense. We add a dense layer with ReLU activation, and then the final layer is the output layer. So we have 10. We have 10 classes, right? So the 10 classes are t-shirt top, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, ankle boot. So so the reason why we have 10 nodes in the last output layer is because we have 10 different classes. And so basically there's one hot vector that comes out. The one in the slot of that class tells us that, okay, the prediction is, okay, here it's a, let's say in the first one would be a t-shirt, second one would be a sandal, and so on. So so let's run this, and it outputs here. So the output here tells us what the model is going to look like, right? And then now we compile, and we run the model. So we run it on 4 epochs with stochastic gradient descent with 108.28 batch size. Okay, so as we train, you can see that the training loss is going down and the accuracy is going up. So the loss is an objective function that tells us, you know, how well our model is doing with respect to the ground truth. And the accuracy is basically the percentage of items in the training data set that were correctly labeled. So we are going to run this for 4 epochs. It's going to take some time. And basically the accuracy is going all the way up and the loss is going down. Now we are, say, on the training data set, we are close to 90% accurate. So that's okay. That's pretty okay. And 91% now. Yeah, so this is a very small data set, and so if you run a larger data set with larger images, the images here are very small, 28 by 28, and they're black and white, so it's very fast when training. But some models can take hours or even days to run, even if you have way better software, hardware. So it really depends on what you're trying to do. Okay, so let's see. Let's evaluate our model on the test data set. Okay, so we now know that our test accuracy is 0.8991. So we can get 89.91% of the labels correct, which is okay for the test set. So if you're giving it 100 images of clothing, you can probably get 89 of them correct or 90 of them correct if you round up. So that's pretty good. Yeah, so let's try to run predictions on all the test images. Okay, so and now we can plot out some examples of what was right and what was wrong. So for this, the model correctly predicted it's an ankle boot, and correctly predicted that this was a pullover. But here we have a sneaker that the model seems to believe is a bag. And here we have an ankle boot that the model believes is a sandal. So these are mistakes that you know, are still being made. You don't have a perfect model yet. I don't think you have a perfect model anyway, but yeah, but this is what is done right now. So this is pretty good with just 2 convolutional layers, and yeah. So this is basically how you train a convolutional neural network to to classify images of clothing. And let me see if we can run this. This is another Jupyter Notebook, right? Okay, so this is Apache license, everyone. Can't use it except in compliance with the license. I hope this, yeah, this presentation is probably fair use since it's a very permissive license. Okay, so this is about transfer learning. Let's see if we can run this. So as you can see, this particular notebook was actually provided to me by online. Actually, it's open source by the people who developed TensorFlow. So this shows you that with Jupyter Notebook, it's really very easy to share your code with people. You can even share, what was outputted, using yeah, you can share what was outputted, and your friend doesn't even need to run it himself. He can see what your output is and can say, oh, this is what the code does. Okay, so let's not run. Is the microphone muted? Is it Dr. Ho or someone?
Sorry, I'm okay. Yeah.
Okay. Right. So we have this Jupyter Notebook, and basically, it tells us that we are going to install this TensorFlow Nightly package. We're going to import matplotlib and everything. And then, so these are the packages we're going to import. And again, we're going to download dogs and cats, a data set from the internet, and this downloads that data set. And this one will split the training and validation data sets. And yeah, so it tells us the batch size, image size. So these images are now bigger. It's 160 times 160. And so now you're getting the data set from directory. Right, so you're loading them, and so the output, you're downloading data from this, and then found 2,000 files belonging to 2 classes. And so now here we are trying to classify whether an image is of a dog or of a cat. So now someone probably prepared this data set. They collected a lot of images of dogs and cats, and they got someone to label, to label whether this image is a dog or a cat manually. So the human is a good judge of what is a dog and what is a cat, but perhaps a computer might find it more difficult to immediately say, oh, this is a cat, this is a dog. So now, so here basically we have a lot of examples of labeled dogs and cats to train the computer to find what it is. So now we have dogs, cats, dogs. And so we are going to basically configure this data set and use data augmentation. So what we're doing here is to rotate the cat around so that there is less of an overfitting problem because the image goes in differently every time you run it through the model, the training algorithm, and then so now you are taking a pre-trained model. So basically this is an example of transfer learning. So you have a pre-trained model that someone already trained using much more data than you have. So it's a very, it could be a very general model trained on more than just dogs and cats. So now you have a pre-trained model, and you can now fine tune it to make it better at specifically solving the problem of identifying whether a picture is a dog or a cat. So now you take a base model and you extract the features. All right, you freeze the base model to say that it's not trainable. All right, and you take a summary of the model. So this is a rather deep model. There are loads of layers in this model, right? And yeah, and so you want to say add your own layers to this model. So let's say you want to add a global average pooling 2D layer, and you add a dense layer to output the basically whether it's a cat or a dog. And then basically you use the Keras functional API to create your new model on top of your base model. So you're taking an input, you are doing the data augmentation, you're pre-processing the input, you're adding on the base model, you're adding on your own global average layer, you're adding in a dropout again to prevent to reduce overfitting, and then you're going to do a prediction layer X in your outputs, and then so basically now you have a model with inputs and outputs. Okay, so now you're going to compile the model, right? So you set a learning rate and you compile the model. You use accuracy. I think percentage means percentage of correctly classified items. And then, so this is the model. You have your input layer, you have your sequential, you have your mobile net base model, and then global average pooling, dropout, and the dense output layer, right? So you train it, and this is for 10 epochs, right? So initially the loss is 0.91 and the accuracy is 0.38. So MobileNet by itself, while it's trained on a very large data set, it should perform well generally, right? So the performance on this task is quite poor. But then once you fine tune it on the training data that you have, the training accuracy goes up, the validation accuracy also goes up, the loss goes down as well, right? Because the loss is a function you want to minimize. And then basically after you train the model, now you are better at predicting whether this each picture is a cat or a dog, right? So yeah, so that's another example of how Jupyter Notebook works. Any questions? That's all the demos I have actually. So